So we have a few examples practicing with the function notation, and we're asked to evaluate g of negative 2, f of 4, and h of 2. So we'll start with that g of negative 2. So what this function notation tells us, first it says the g, and that will direct us to which function we should use. So we know, all right, we have to use our g function for that. So, g of x is equal to 2x minus 1. That's the function we're going to evaluate. And now where it says g of negative 2, when they put a negative 2 in place for the x, what they're saying is, well, what is the value of the function when x is a negative 2? So all that we do, and you'll see from this point forward, I'm only working on the right side of the equation. I'm done with that g of x or g of negative 2. On the right side, I'm just going to plug in a negative 2 for the x and then evaluate this. So 2 times negative 2 is negative 4 minus 1, and we get a negative 5. So g of negative 2 has a value of negative 5. Next we have our f of 4. So we see the f, and that tells us, okay, we need our f function. F of x equals 4x. And then this 4 tells us what to plug in for x. So we're going to plug in a 4 for the x into our function. So we're going to do 4 times 4, and then we get back a 16 as our final answer. So f of 4 equals 16. Lastly, we have h of 2. The h tells us, let's take our h function, and I'll just write it down here. H of x equals 5x plus 2. And then we want to evaluate it when x equals a 2. Again, I'm only working on the right side. I'm going to plug in a 2 for that x. So 5 times 2 is 10, plus 2, and we get back 12. So function notation, that's how we use it. It really is the same thing as just y equals, so don't let it throw you off. It's just a new way to write y equals. Helps us differentiate between our different functions.